Assalamualaikum, good morning. So in this video I'll explain on a vector field. Okay, this is a vector field. As you can see, this is a wind speed and wind direction. Okay, for vector field, this is a wind direction. As you can see here. Okay, if every point x, y, z of region R of a space is associated with a vector quantity, okay, is a vector function. Okay, and a vector field is said to exist in the region R. Okay, for example, such as force, acceleration, velocity. Okay. Okay, this is the example in a 3D for x, y, and z. Okay, how to graph a 2D vector? Okay, first need to plot a several vector in the vector field by selecting x and y values in the coordinate plane. Okay, sometimes it is helpful to plot several vectors with the same magnitude. Okay. Graphing software is very helpful with plotting vector fields. Okay, but in this video, I'll explain how to do it manually. Okay, if you want to do by using a software, so it's better than do the manual. Okay, for example, sketch the vector field for function xy is equal to vector I and plus vector j. Okay, either we write in this form or you can write in this form. Okay, both is similar. Means the meaning is similar. Okay. Okay, take several points. You can take any point. You can assume. Okay, for example, this is the several point that I choose. Okay, then draw the graph. Okay, this is the x and y axis. Okay, and this value for x and y. So I'll take as one point, for example this point, so this point is negative to 0. Okay, then right at the one step right. Okay, because we have a vector I, vector I mean only one I, so we go to one step I and one step y. One step to the right and one step to the above. Okay. This is the vector, and the orange arrow is the vector. Okay. So can you understand? Then we do for another point. Okay, for such as we do the for negative 1, 0. Okay, so we repeat again, one step to the right and one step to above. Then the vector is this orange arrow is the vector. Okay, then continue. I repeat again 4.00. So one step right, one step above. Again, I get the vector. For the orange, the orange arrow is the vector. Then I do 4.10, so I get the similar error, similar direction. Sorry. Okay. Then this point for negative to 1, one step to right, one step to the above. Then we get the direction of the vector. Okay. This is how we write. We do the graph for vector manually. Okay. So you can choose another point. It's better to select the point at each. Okay. Sorry. Okay. This is the example for this vector. Okay. So that is the direction of the vector. Okay, then I show another example. So sketch the vector field for x vector I and plus y vector j. Okay, so it's better to develop this table. You can assume any point that you want to. Okay, this is the point that I assume. Then this is the vector for xi plus yj lah. Okay, if the point 0, 0, so the function sy is also 0. Okay, how to draw a graph? First, you write the y and x axis first. Okay, this is a 0, 0, because the xy is a 0. Okay, you can choose any point that you want to. This is this point that I selected. Okay, then I draw the graph here. Okay, so the x and y axis. So at the point 0, 0, this is the point that selected lah, based on the table. So at the point 0, 0, the function is also 0, 0. Means there is no direction go to the right, go to the left, or above or below. So they stay at the point 0. Okay. Then we repeat for another point. For example, point 1, 0. Okay, this is the point for 1, 0. So the function vector is 1, 0 also. So you go to the right, one step to the right, and there is no step above or below. So this is the direction of the vector. The orange arrow, the orange direction. Okay. Then I do for the point 1, 1. Okay, one step to the right and one step to the above, and that is the direction of the vector. Okay, then we repeat again for another point. For example, 0, 1. So 0, 1, and there's no direction for left and right, just one direction to the above. Okay, then this is the direction of the vector. Okay, then I repeat again for point negative 1, 1. Okay, it means there's one direction to the left and one direction to the above. Okay, then the direction of vector, this is the direction for vector. Okay, then I repeat again for negative 1, 0. So we go 1 to the left, and there is no direction to the above or below, so the direction of vector. Okay, that's how we do manually to develop a vector graph. Okay, then you can include lah another point. There is the another direction. Okay, to complete this one, okay, I show that this graph of the vector. Okay, you can see lah. Okay, now we go how to find the line integral of the vector field. Okay, what is the line integral? Okay, line integral, okay, such as I draw this one. So this is the vector field, maybe such as for the wind direction, for example. So the line integral, we have the line here. Okay, and when we say the line integral, actually is a surface area lah, below the dotted line. Okay, so this is the formula how to find the line integral. The f function, f is the force, and times a dr. Okay, so this is the formula. I think the formula is given in your test or in your final exam, so no need to memorize lah. Okay, actually this just for your information, how to they establish this formula. Actually from previous chapter, in the previous video, so this is ds, force and tangent. So when you integrate force times t is tangent and ds, and tangent is dr over ds. Okay, and ds is the ds over dt times dt. Okay, so when you simplify this one, okay, means you remove all ds dt, then you get the formula for f dot dr. Okay, but this is just for your information. The important thing, you need to use this formula lah, integration f dot dr. Okay, f is the vector field and dr is the vector lah. Okay, so this is the formula lah. Okay, so you see the one example here. Okay, the f dot dr where the vector field is. So this is the equation along the segment line, from A to B. Okay, so they are given from one point to another point. So first what we need to do, we need to do a parametric equation. Okay, so this is the formula for parametric equation. So I just repeat again. So x equal s0 plus wt. So at t equal to 1, x is equal to 2. Okay, because point x is 2, x s0 is 1 plus wt, t is 1. So now we get w is 1. Okay, so the parametric equation is 1 equal to 1 plus t. Okay, because w is 1 lah. Okay, then we repeat again for the vector for j and vector for k. Okay, so y equal to 3 okay, negative 1 minus negative 3, we get negative 40. Okay, so z is equal to 5. Z equals to 1 plus 5 minus 1, so you get 40. Okay, so this is the parametric equation for this, from these 2 points. So how to find the interval for t? Actually, commonly the interval is between t is equal to 0 until equal 1. But you can confirm by using this one. Just include the 0 in the parametric equation, so everything is right. So you get the interval is between t0 and t1. This one you repeat again lah for t1. Okay, So now we have all the information. We can do the line integral for this vector field. Okay, function. Okay, function the vector field xyi plus sy. Okay, so this one we can replace with the parametric equation. Okay, so x is equal to 1 plus t. So you can include here 1 plus t. Okay, y 1 is 3 minus 4t. Okay, so this is for vector I. Then we repeat again for the vector j. J is x plus y. So we just include 1 plus t here. Okay, then you plus with the 3 minus 4t. Okay, so this for vector j. Then we repeat again for vector k. K is just z. Power of 2, so z is 1 plus 4t. Okay, power of 2. Oh, sorry, the t is missing. Okay, then how to find the dr? So dr we need to based on the r. R is a x I plus yj plus zk. So what is x? X is a 1 plus t. Okay, I write first. Okay, equal to x is 1 plus t for vector I, then y is 3 minus 4t for vector j, and z is 1 plus 4t for vector k. Vector k here, z, y, do right with z. Then we differentiate this one. 1 plus t, if you differentiate you get 1. Okay, negative 4t, differentiate you get negative 4, and lastly is 4t, you get differentiate you get 4. Okay, 4k. Okay, then we integrate the interval between 0 and 1. So vector field f, so just include in the equation here. So 1 plus t, 3 minus 4t, then you times with 1. Okay, okay, this is for vector I. Okay, then we repeat again for vector j. Okay, if you can simplify, better simplify lah. Okay, 1 plus t plus 3 minus 4t. So I think you can simplify this one. Okay, then this one times with negative 4. So for this one for vector j. Okay, then lastly for vector k. So vector k is 1 plus 4t. Okay, power of 2 times with 4. Okay, then you calculate lah. I think all students can do this. Just calculate. Then include the interval. Okay, I think better I just show in this slide. You can refer to the slide. Okay, and the final answer is 32.5. Okay, that is how we do for this line integral for the vector field. Okay. Okay, so this is the line integral. So what 32.5 is just a surface area between this line integral lah. Okay, in the vector field. So this one is the vector field. Okay, one application by the line integral of vector field is the work done by the force field. Okay, for F is the force of field, for example gravity, electromagnetic, and etc. Okay, so work done is equal to force times a displacement. Okay, so this is the formula lah. Okay, for example find the work done by force field. Okay, so this is the equation for the force field. Okay, along the curve C. Okay, where C is the upper semicircle. Okay, upper semicircle. So I just draw the semicircle here. So it's starting from 0, 1. So where is the 0, 1? It means at this point, and end at the 1, 0. Okay, so this point, and this is very important because you want to find the value for the interval. So this one is from pi over 2 equal until to 0. Okay, okay, so this one is semicircle. So when semicircle, better do in the use a x equal to cos theta. Okay, so in this case we use t, we don't use the theta lah. So y is equal r sin theta, so y equal to 1 sin t. Okay, okay, so it's starting from pi over 2, okay, 90 degree, and until 0. So to find the line integral, f dot dr. So f is the based on the equation given is yi, okay, plus, okay, and blah blah. Okay, so this y, better you convert lah, y equal to sin t lah. Okay, so in vector j, x plus 2y vector j. Okay, so just include the x equal y equal to sin t. Okay, sin t for vector I plus, so x is a cos t plus 2 sin t. Okay, so this for vector j. Okay, okay, and for r it is equal to x vector I plus y vector j. Okay, what is x? X is equal to cos t for vector I plus sin t for vector j. Okay, then you need to differentiate lah r to get the dr. So cos t, when you differentiate, you get the negative sin t. Okay, and sin t differentiate, you get the cos t. Okay, then you can include in the formula. So f dot dr from pi over 2 until 0. So this is the value for interval. Okay, sin t, okay, times negative sin t. Okay, because f dot dr, so this for vector I, plus, so this one cos t plus 2 sin t, okay, times with the cos t. Okay, sorry, time with the cos t here. Okay, for vector j. Okay, so now we have a sine power of 2. Okay, negative sine power of 2 okay, plus 2 cos t cos power of 2t and 2 sin t cos t. So when do you have a sine power of 2 cos power of 2 so you need to use the trigonometry table to integrate this one. Okay, you need to convert lah. Okay, we can convert sine power of 2. So a conservative force is a force with the property that total work done is moving for particle between 2 points independent of taken path. Okay, for example this one either is go to the red, green or blue so it finally go to the same point, so we call it as the conservative force field. Okay, for example this guy want to throw a ball. Okay, this is the ball, so it go direct way in this way or in this way or just kick the ball. So finally go the same point, so we call it as the conservative force field. Okay, so this is a work type. Okay, so the conservative force field this is the formula. Okay, a conservative field is a vector field where its integral along of every closed path is a 0. So for example such as gravity, static, electric and magnetic field. A non-conservative field is one where the integral along some path is not a 0. So for example wind velocity so this is called as the non-conservative. Okay, this is the example that I want to show you the conservative force field or we call it as a work done. So this is vector field and this point move from point 0, 0 until to 4 So as you can see they have 3 paths C1, C2 and C3. So we just want to confirm this is the conservative or non-conservative. Okay, so we need to do one by one path and we compare. Okay, first we do for the C1. So C1 and this is the integral f dot dr. So the vector function xi plus yj. Okay, this form equation we can develop the equation here is y equal to 2x. Sorry, this line we develop the equation is y equal to 2x. Okay, so now we have xi. Okay, then y we convert to become a 2xj because y equal to x. So we do in the x direction. So r equal to xi plus yj, and this is the vector here. So xi plus y is a 2xj. Okay, then to find the dr, if we differentiate x, we get the 1. So I plus 2x, we get differentiate, we get 2. Okay, so I plus 2j. Okay, then I include here the dr. Okay, then times x times 1, we get x lah. Okay, okay, x, okay, plus 2x times 2, you get the 4x, okay. Then we integrate to the dx. So dx here is between 0, so it is starting from 0 until 2. Okay, so the value of interval 0 until 2. And then you can differentiate as usual. X you differentiate, you get the x power 2, you differentiate, get x power 3. Okay, then you can solve it. You get the final value is equal to, okay, now I just should wait. Now here, put here, and we get the final value 10. Okay, so we have done with the C1. Now we continue with the C2. Okay, so C2 based on the graph. Okay, the C2, what is the equation for C2? Okay, equation for C2 is y equal to 2x. Okay, sorry, y equal to x power of 2. Okay, then we repeat again. Similar calculation, almost similar lah. Just for the y is equal to x power of 2. Okay, then we will find for r vector, and the dr is equal to 1 I plus 2x for vector j. Then f dot dr, okay, then you times x times 1, you get value x. Okay, plus x power 2 times 2x, you get 2x power of 3. Okay, dx. Okay, so this one the interval also similar, between 0 until 2. Okay, then integrate as usual, and then find the final answer. Final answer is similar with the C1. Both is 10. Okay, then we do for the last one, for the C3. So you can see here, C1 is 10, C2 is 10. What is the value for C3? Okay, C3 they have two direction. Okay, so we need to do twice. Then we total up. Okay, s equal to 0, and this one is y equal to 4. Okay, when x equal to 0, dx equal to 0. So r equal to xi plus yj. So x now 0, so we only have y. Okay, for dr, only have j. Okay, j dy. So f dot dr is equal to, so this one is between 0 until 4. Okay, then here we get the si plus yj times dr. So the value for dr is j dy. Okay, there is no value for x, so x equal to 0. So this one is yj times j. So you can integrate lah. So when you integrate this one, the final answer will be equal to 8. Okay, then you repeat again for another path. Y equal to 4. Okay, so y equal to 4, dy is 0. So r is xi, okay, plus yj. Y is a 0. So the dr is I plus 0. Okay, then you can find the f dot dr. So interval is between 0 and 2. Okay, xi plus yj. So the value for x and y value for y is equal to 4, y equal to 4 times the dr is only have a I, okay, I plus j, okay, j is, there is no value, so 0, I just remove here, dx. Okay, so x times 1, you get value for x. Okay, x dx. So now we have 4, when we integrate we get the have no value. Okay, okay, final answer is 2. So x plus 2 equals to 10. So C3 we get the value also 10. So this is the conservative force field. Okay, so this is the example how to find the conservative force field. Okay, this is the information from the slide. So we get all the path, we get the same value, all the value is 10. So this is the conservative force field. So conservative force field is equal also for the curl F. Okay, so how to find the curl F? Curl F is this is the formula, must be equal to 0. Okay, so this sample I show you how to use the curve F. Okay, given the force field x plus yj, show that it's conservative by finding the potential function we specified. Okay, curl F. So curl F, so this method is the either way. Okay, is equal to this is the formula. So the formula is in the metric form. Okay, d dx and this one is d dy. Okay, so d dx is x, for vector j is y. So when you get this form, I think you know what you need to do. D dx times y minus d dy times x. Okay, so both is equal to 0 lah. So when both equal to 0, so this is the conservative force field. Okay, so this is another way to find the force field is conservative or not conservative. If you get the value is not 0, so there is a non-conservative force field. Okay, the extra work, they ask the conservative by finding a potential function. Okay, but I'm not recommend for this method to find the potential function, because sometimes it's quite difficult to understand. Okay, so to find this one, we need to find this one. Okay, I just write here first. Okay, this one is equal to xi plus yj okay. So for vector I, d phi over dx equal to x. For vector j, d phi over dy equal to y. Okay, so when I bring d phi to the left hand side, so this one x equal to dx, so d phi is equal to y dy. Okay, so when we integrate this one, you will get phi equal to x power of 2 minus 2 plus, okay, there is we could put any constant lah, okay, fy for example. So this one phi equal to x, y power of 2 divide by 2, so another constant gx. So for this, for equation 1 and 2, then okay, 1 and 2, so phi is x power of 2 over 2 plus y power 2 over 2 plus the h. Okay, then we compare lah, 1 and 3. Okay, this equation for 3 lah. Is it similar with 2 and 3? So if similar, this is the conservative. Okay, if not similar, that is not the conservative. We compare the equation by equation. But sometimes quite difficult when we compare equation. So it's more easier we find the final answer for the previous example, find the 10, 10, 10, so we compare, so all value is 10. Oh, sorry. Okay, then there is the conservative. Okay, so there is another method lah to find the conservative force field. Okay, that's all for the integral, line integral of the force field. So please do the assignment. If you have any problem, please WhatsApp me. Okay. Okay, this is the information from the slide.